Hi, Steve. Welcome back. And what I did right before the show, I just opened the Payara Fish website. And the first thing what I see is 275% of commercial support growth. And it seems like you are really doing well. So since last time, I found some of my friends from JavaE specs working now from Payara. So how Payara is doing?
Payara is doing very well. Like you said, we're growing pretty rapidly. We're about 60-70% revenue growth year on year, and the number of customers is growing quite quickly. Getting more and more staff. I think we're about 30 people now, and we've got a great team, and we've got a great vision of where Payara Server and Payara Micro and Jakarta EE and those things need to go in the future. So we're set up to have a very long runway. We are funded purely by customers. We have no venture capital. So as long as customers keep paying for our software support, then we can carry on and drive forward Jakarta EE for a long time.
And this is actually incredible, because what it basically means that your 30 employees are founded by commercial support of Payara, right?
Yeah, that's right. Yeah.
So this is actually very good news. Well, what actually means that JavaE, Jakarta, and MicroProfile are far more popular than one might think, right?
Yeah, they are very popular. There's still a lot of people using Jakarta EE, MicroProfile, Java EE. All the hype, the Silicon Valley hype around all the things that are cool, around Kubernetes and microservices and all that stuff takes a long time to work its way through, big organizations. So they're still using Java EE. And obviously, there are also a lot of traditional applications out there. Those applications don't need any of those technologies, and those applications are still very much focused on building, Java EE, Jakarta EE applications to serve, the needs of those different types of applications. And not everything is a big internet scale application.
This is interesting what you're saying, because in my world, most of my clients are actually running a kind of Kubernetes, Docker, and microservice, and they are still using Payara and JavaE. So what I see more right now is a combination of Kubernetes, OpenShift, Docker, and JavaE. This is also what you see, or you are running on bare metal mostly?
We see both. So we've done a lot of work to get, one of the things that we did when we set up Payara was, one, obviously to take support for GlassFish application server, but the other goal really was to take Java EE developers onto new platforms. So obviously Java EE's development API has been very successful and will be very successful in the future. What we wanted to do was take people onto new architectures and new platforms. So we've done a lot of work to support Kubernetes, containers and Docker and cloud platforms as well. So we're seeing both really. We're seeing Kubernetes and Docker as an infrastructure platform, and then deploying Java EE applications on top of that, both in full server and in micro. And then similar to that, we're also seeing a cloud adoption as well. But there's still many people that deploy into traditional data centers. For we have customers from many different verticals. So we've got people building manufacturing systems that are going to go out on factory shop floors, and they'll be running within traditional server hardware as well.
Yeah, this is also what I never understood, because Kubernetes or Docker for me is not a programming model. So you cannot just run a Docker or Kubernetes application. So you will have to do something inside. I mean, you need a programming language. You need something. So this is not that different to what was before. And for me, the programming model from MicroProfile, Jakarta, and JavaE, they are actually very productive. So with Jakarta or MicroProfile, we get a productive and proven programming model, which can be run on bare metal or Kubernetes, right?
Exactly. Yeah. I mean, so to support Kubernetes actually doesn't take a lot of effort, because it's very much of an infrastructure type technology. It's not a programming model in its own right. The only thing you need to do is understand the sort of immutable nature of containers and build that into your runtime so that you can move from one environment to another, and support that. So it's not the programming model that has to change. It's more the runtime ourselves. So they say Java EE microprofile is very productive to build applications that can run within Kubernetes infrastructure, and that could be doesn't have to be a microservices application to run in a Kubernetes infrastructure. Exactly. But what we had to do, sorry, yep.
Because if you consider Kubernetes in particular, so actually what the only thing what is different is what you would have is like the key value pairs called DC deployment configs are stored in a YAML file, and the Payara could just understand the configuration, which already happens natively. So Payara can resolve the variables in the config XML, and the microprofile can even provide you the key value pairs via injection. And there's also Kubernetes thing is like the CPU and memory requests and maximum, but this is more like the Java SE thing and less like application server thing. So what I'm interested in now, what you did in particular, to support Kubernetes better.
It's basically what you said there. So we did work. So we've done a few things, and we've done some in the latest release as well. First thing was to externalize config and read that configuration from from Kubernetes, or essentially get it provided by Kubernetes through secrets directory or through environment variables. And what we did was we externalized things like JDBC URLs, JDBC usernames, passwords, connect strings, anything that would change from environment to environment. We supported variable replacement within the deployment descriptors for like data sources, etc. That's one thing we did, and that allows the user's application to be able to fire up and move between pre-prod and prod or whatever. The other thing we did was we basically changed our clustering so that it could discover other nodes. So to create a cluster or a data grid within Payara, you need to know where the other nodes are, the other instances of Payara running. So we've extended our cluster discovery mode to include looking up Kubernetes service, so that you could use a Kubernetes service name to find the other instances of Payara and then cluster them together. So that's another thing that we've done. And then as we move into later releases, there's a couple of customer requests that we've got. One is to start sort of extending the application server domain mode to support nodes running within Kubernetes itself. So the latest release has some first cut functionality whereby a Payara instance can run in a Docker node, in a Docker container, and Payara, the admin server, can talk to Docker to start and stop that server. And as we go further on and build on that functionality, that will support dynamic instances and can also do some work around maintaining a certain number of containers running Payara and allow it to scale up and scale down. So we can take some of that functionality that maybe provided by Kubernetes and allow the DAS to actually visualize those servers. And one of the other requested features from customers was...
Wait a second for this, but this is really interesting. So as you said, this would be like a small Kubernetes replacement, a part of the scheduler. And what this would mean is we could get, let's say a Java API to control nodes, Payara nodes dynamically on Docker, right?
Yeah, that if you didn't have Kubernetes, you could do that. That would be so. Basically, we've introduced a Docker node type into Payara, which Payara has node types of like SSH and things. We've introduced a Docker node, and the admin server can start and stop those containers on any machine that has Docker on it.
Because then we could, for instance, create a dynamic scalability based on some business metrics, right?
Yes. That's not there yet. That's the plan, was to be able to create dynamic scalability based on that.
This is actually a feature which I didn't thought about. It's like, what the application servers are able to do is just to start and stop instances, what they usually did with Payara's domain server, and WebLogic also did it back then. And what I remember, there was a demo JavaONE, a presentation probably 10 years ago, before Java 7. It was supposed to be, the Cloud Java E edition, and they already did a demo with the old GlassFish 3, I think, where they were able to dynamically start and stop instances without Docker. You remember that?
I do remember. I was actually there. Yeah, I remember that. And they were using the Sun Cloud as was. That never got released.
Yeah,
I think.
Yeah.
So it's sort of similar to that. And the other thing that we need to do is obviously the DAS needs, one of the advantages of an application server is a managed runtime. So I'm a great believer in managed runtimes and what they can do for developers. So the other thing we'll be able to do is obviously you even if you just, ignore the DAS starting and stopping instances, what you do want to do is have visibility into that server and what's happening within it. So we'll be extending sort of the monitoring and the visibility of what's happening within your application, within a Docker container, through the DAS, through the domain admin server.
So what you could also do is, for instance, aggregate as an additional feature, the microprofile metrics, because right now every node would emit, isolated set of metrics. With that, you can actually aggregate them, right?
Yeah, exactly. We could aggregate them. We can do tracing across them. We could graph them and collect them all as a central point. So it's basically extending what would be the normal domain architecture, but into the infrastructure that is Docker and Kubernetes. One other one that was requested by customers is running up Java in pods. Is that sometimes Java will, go away. The pod won't crash, but the application will become very unresponsive. So another feature that customers have asked for is that, when a Payara instance is running in a pod or a container, that it basically indicates to the admin server that it's still alive through a heartbeat through the data grid. And so we've got heartbeat monitoring in now, but we haven't got the point where basically the DAS would kill that pod off so that Kubernetes could potentially manage the life cycle of it, but the DAS would be monitoring and managing the sort of health and metrics within it.
Actually, you could even extend Kubernetes by providing like a Payara DAS operator for it, right?
Yeah, you could do, yeah.
Yeah, this is a true innovative stuff. This is really interesting idea, I have to say. It's really interesting. And what I want to ask you, you are talking about the cluster. So the question is, why we actually need still clusters in Payara? So because traditionally, back then, the HTTP session and stateful session were clustered, but this is, I think there is no more use cases for that. So what are you clustering right now?
You said there's no use cases. I mean, what are the use cases for clustering, really? They are just bringing data close to the processing. So Payara basically has a full data grid built into it, so it gives you the ability to do that. You don't have to do it.
Yeah. So what cluster means right now for you is distributed cache, right?
Yes. Yeah.
Okay.
Yeah. As opposed to failover and things like VGBs or whatever.
Yeah, but traditionally clustering meant, smart proxies, which got the view from the application servers about the IP addresses, and the smart proxy was the load balancer. So this was traditionally what J2E clustering meant.
Yes. Now, that's an interesting point. So is that use case gone? Because you could put it through a load balancer and things for HTTP, but then that's another thing to manage. It would be possible to create a smart cluster on the JAX RS client side. Sorry, smart proxy on the JAX RS client side, especially within the current microprofile REST client API, which is actually tending towards almost the EJB client API in the sense that it's type safe.
Yeah. So
it's actually possible to resurrect that on the REST model and actually have a smart proxy on the REST client side that could do load balancing.
Yeah.
Through a cluster without load balancers.
Exactly what I said is, the old EJB use case is probably gone because this, Corba and IOP remoting was replaced by JAX-RS, but now we have JAX-RS. And in your world with the semi Kubernetes like Payara, you could use instrument the JAX-RS client to provide the runtime information, so you get a load balancing through JAX-RS, right?
Yeah, the JAX-RS client can look up a Kubernetes service name, get all the endpoints, and actually load balance them itself.
Yeah, because right now in OpenShift I do something similar, but how it works is you get the logical name of the service, and then there is the load balancer provided by OpenShift or Kubernetes. Yeah.
So you could do either. I mean, because you can actually, say, look up the service and actually just find all the endpoints where that REST API is hosted and load balance them yourself without an additional infrastructure, if that was needed.
And how are you doing this with Kubernetes? Are you using a native API or the REST API from Kubernetes to find out the services and the where the nodes are running?
I believe we're using the REST API.
Okay.
I didn't write that piece.
No.
But one of the things we try to do is minimize dependencies.
Yeah.
So I imagine we'll be using the REST API raw rather than bringing in a Java API, because that will probably bring in a lot of other things that we don't want into the application server, a lot of transitive dependencies.
Okay.
So a lot of the time we do this thing raw.
Okay. So basically, if you are mentioning clusters, what you usually mean is caching, distributing caching or distributing.
Yeah, that's what we call it. That's why we call it data grid now.
Data grid, okay. And
because we split in Payara 5 the concept of clustering apart. We created deployment groups, which is a unit of target. So another reason what clusters were used for was to obviously target a deployment to say put it across these 5 servers in a cluster, in quotes. So we have deployment grid, which is basically distributed cache across all instances in the domain by default. So you don't care where your data is being stored. So you don't need to have it in a cluster. And then deployment group, which is I have this group of servers and I want to deploy this application to it. So we split those two concepts apart now. So we have deployment groups and then a data grid.
Yeah, perfect. So that's also interesting. And this deployment group is what you can do. You can deploy to one server and the deployable is distributed to all other servers, right?
Yeah. So you basically, when you deploy an application, you target a deployment group and all the servers in it will get that application. And you could take a server that's running, modify it, put it in the deployment group, and then it would deploy all the other applications that are targeted to that group. So you could take them in and out of groups, which is something you couldn't really do with clusters. So the idea would be longer term is if you follow Kubernetes to its logical thing. I mean, Kubernetes should be an infrastructure for managing thousands of nodes. You don't build like a single application that is just one Kubernetes cluster. So the idea would be if you've got a lot of Payara instances running on a lot of pods, then you could take one of the instances and change what deployment group it's in, and it would get all those applications and it would deploy them. Yeah,
this would be a replacement of Docker image, right? A particular Docker image loaded with ThinWar and Payara on top of it, right?
Yeah.
Okay. Also interesting. So what else you did on top of plain Java? So what is the added value, let's say, of Payara Full and Payara Micro?
So, I mean, we are trying to stay pretty straight on the actual APIs that we support, but both Payara Server and Payara Micro support both microprofile and Java EE or Jakarta EE as will be applications. And that's our intention, is to keep that. There's no reason, it depends on what the groups do, whether they split or merge or stay apart. It doesn't really matter from our customer point of view, as we'll support both APIs. The rest of the stuff that we concentrate on really is to take advantage of an application server as a managed runtime. So I sort of mentioned that we see great value in managed runtimes. So a lot of the work we're doing is really on the server itself rather than APIs, and it's to visualize and give a developer insight into what's happening within their application. Obviously, Java EE, microprofile, they abstract a lot. There's a lot of magic annotations and things like that. So what we want to do is basically take advantage of us being the code of the application server to visualize a lot of what's going on. So what we built request tracing into it. So every request that goes through the server is getting monitored. And if it exceeds a threshold, then we can log that out with all the events that occurred. So, which EGBs were called, which servlets, which CDI beans, any outbound calls, those sort of things. Mm-hmm. And also to monitor what's happening within the database, how and why your application may deploy, try to take a long time to deploy. So we're building a lot of that sort of infrastructure. Mm-hmm. And the next couple of releases, we're going to see a lot of that visualized within the administration console. So we have a lot of the internals built. What we need to now do is actually make it much easier for a developer to see that information. Which
is very important, I think. So, nice diagrams and graphics, they make a huge impact. To tell you a short story, it was back then as Histrix was still available. So I was in Java user group, and a consultant came to me afterwards and say, okay, what I really do is I create a lots of Histrix diagrams, and I say, do you really need them? Say no, but they look more professional, and I can pay something, or I can charge my client something, and they really like nice graphics. But it was like, how do they use them? I'm not using them all, but they are really nice. And this was like, it's like, okay, this is also interesting take, right?
Yeah, exactly. Yeah.
And
but yeah, it's that visualization of what's going on. I mean, at the end of the day, you probably shouldn't need an APM tool to see what's going on in the application server. The application server should be providing all that information for you. The APM tool should be the next level up. Really, that's aggregating that information and presenting it potentially historically across many servers and many calls. But from a runtime point of view, we should be providing that information.
Yeah, absolutely. I don't know whether you are still aware of it. I created a tool 10 years ago called Lightfish back then. And
yeah, I remember, yeah.
Yeah, and in one point of time, I got lots of commits. I wondered why it is so popular, who contributes lots of code. And it turned out that the Canadian government used, the Lightfish to monitor the server instances because they wanted to replace an APM tool. So,
right.
Absolutely. So having something built in is very important for me. And also, you can get more, context-sensitive, metrics. The longer you wait, the harder it is to find out what actually really happens inside the application, right?
Yeah, exactly. I mean, we want to be able to detect what's going on and, provide guidance. One of the things we see a lot of is applications that suffer from Maven, really, bringing in lots and lots of transitive dependencies. So one of the things we're building is a deployment analyzer to say, hey, you've got all this stuff in here. Half of it's in the server already, and provide guidance like that about what to take out or what to make it faster.
Yeah,
and to make deployment faster, and sort of guidance on what to avoid scanning and things like that.
Yeah, absolutely. This is also my opinion. So first, use Java SE, then Java E, and then if something lacking, then take a look at third-party dependencies. That do not start, to find something exciting on the internet and include it to your war. It usually causes trouble over time.
Yeah, I mean, I'm helping another open source project migrate onto Payara at the moment, and their WAR file is 250 megabytes in size.
Yeah.
And which is almost twice the size of or 3 times the size of Payara Micro. So, but it's a lot of it's transitive dependencies that are difficult to remove. It's a lot of Maven excludes and things like that just to get rid of stuff.
Yeah,
that's been pulled in.
Mm-hmm.
Including Xalan and Xerxes, which shouldn't have been there for a decade, to be honest.
Yeah. So. What I did for a startup, actually, I don't know whether you are aware of my GitHub project called Payara S2I. You saw that?
Yeah.
And what they asked me is how to have Jenkins pipeline and repeatable builds. And they already knew GlassFish, and they asked me, what is my opinion about Payara Micro? And I said, okay, for me, it's like Payara Micro optimized Payara Full, but if you already know GlassFish well, so just go with the Payara, because it's like, GlassFish on steroids, so it's patched GlassFish, and it will be pretty much the same. And then, the question how to configure like data sources and Postgres JDBC drivers on Payara. So, okay. So OpenShift has is like the S2I image. So what I will do is to create a builder, which will where you can put the pre and post boot command scripts, and the client could just add as admin commands. So the migration was very easy. They just took them their as admin commands and just check them in, and this basically was. So was it the right choice, to use the Payara Full, or would you say Payara Micro would be a better choice? Because in my eyes, is that the Payara Full is a little bit more popular still, because of course it's completely based on GlassFish, and my idea was if they have particular questions, so they will find easier answers on Stack Overflow without my help than for Payara Micro. So this was the basic thinking. So was something wrong with my decision, or I get some support from your side?
Yeah, I mean, there's nothing wrong with the decision at all. Payara servers designed to also run within containers and container platforms as well. Payara servers obviously supports more APIs than Payara Micro, and therefore can be used quite happily within a container environment like that. I assume that you strip out the admin var and things like that. So, I mean, it depends on what people want to use. So Payara server, as we go forward, Payara server is targeted at a traditional application server topology, have an administration server and a bunch of managed servers. Whether that's running on Docker or Kubernetes or bare metal doesn't really matter. That's how we'll go. So if you need that sort of model and you're only going to run maybe 2, 3, 4 servers, then that's the right sort of runtime to use. And you want to have an administration server to look at them. That's how we would recommend Payara server. Saying that, there's nothing stopping people dropping them into multiple DASs, which other customers do. A single administration server, not in a domain, within a container. That's essentially what Payara Micro is trying to do.
Because with Payara server, if you a starter, a developer, you could even expose on Kubernetes the port 48 and 48 for in development stage. And then you could even, play with the administration console and then copy down the config XML. So at the beginning, it could be more pragmatic, right?
Yeah, you could do that. You could do that for a long time. And like I say, as we go further on, then you could have a DAS running in one Docker container and a bunch of managed instances in others, and be able to visualize them and see them. Yeah, but in one
point of time, it will contradict the immutable infrastructure idea, where the runtime does not change. So this is the point. But at the beginning, could be very helpful, to have a visual console where you can just configure whatever you like and download the domain XML, and then rebuild the Docker image and push it again to the cloud.
Yeah, absolutely. And there's nothing wrong with that model at all. I mean, as time goes on, Payara Micro is going to go more towards the, pure microservices runtime, where it just runs on its own within a container and has no concept of other servers and how you would manage them. So as time goes on, that will sort of heavily focus on that use case.
And how compatible are they? I just could basically, take the configuration from Payara Full and reapply in Payara Micro, right?
At the moment, yeah, they're pretty compatible. If it was just for the, you're just monitoring you're just modifying effectively admin server's config, the server config.
Yeah.
Then you could take that and drop it onto Payara Micro.
Yeah. So if someone comes from GlassFish and already knows GlassFish well, then the idea would be start with Payara server, and then if you are confident what you are doing, just you can migrate over to Payara Micro, for instance.
Yeah, that you could do that. And Payara Micro doesn't support the full set of APIs, but it supports most of them.
Yeah, and what in my eyes, what actually would speak against the decision to run Payara full in the clouds is the attack surface, right? Because the Payara Micro doesn't have the admin console.
No.
There is less stuff exposed, right?
Yeah, it doesn't have the admin port exposed or anything like that. So there's no way you can remotely run commands on it or anything like that.
But on the other hand, on Kubernetes or Docker, you will have explicitly exposed the port 4848. So this is it won't be available per default. You will have to do something with it, right?
Yeah, exactly. Yeah.
Mm-hmm. And so I would say from runtime perspective, I would say both are comparable, right? If I would launch Payara Micro and Payara Full, and in Payara Full, I wouldn't start localhost 4848, so the admin console won't be loaded because it's lazy. Then the runtime, in my observation, are very similar, right?
Yeah, they're very similar. There is a different boot cycle. Payara Micro doesn't run on top of OSGI, which Payara Server does, so there's no OSGI in there. That's the only other real difference from a pure runtime perspective.
How much memory could we save just running, Payara Micro or Payara Server? Do you have something? How many megs?
Payara Micro can run in, tens of megs, whereas Payara Server it's not huge, but it probably needs a couple hundred megabytes.
Mm-hmm. Because what I did, I measured the Payara Micro heavily, and in idle cycle, it just consumes almost nothing. It's like 64 megs or something. This Payara full, and the Micro is even smaller. But if if Payara full already comes with 64 megs, so what you can save is just the 64 megs. So
it's not a vast difference. I mean, Payara Server is really light anyway. I think that's people forget. They think it's going to be much more heavyweight, but it's not actually. It's actually the actual kernel code is identical, other than the fact that there's no OSGI. So there's a bit of OSGI overhead in Payara Server, which isn't there in Payara Micro. But both of them are, which pushing to be smaller and leaner. So
I don't know whether you remember, but I would say 5 to 10 years ago, regardless, when I said something slightly, I would say, how to call it, slightly less optimistic against OSGI. I got about 100 comments on my blog, like, how you dare, OSGI is the technology from future, and you can create, modules. And now you are removing OSGI from the server, right?
In Micro, yes. Not necessarily from the server itself.
Yeah. But it's interesting, right? No one speaks about OSGI anymore, right?
We still get some issues raised, mainly on open source, about deploying OSGI modules into Payara Server. But I don't think we see it in any customers.
No, but I mean in general, there's there are almost no more talks about OSGI. There is no articles. The OSGI is completely silent, right?
I'm not following. I don't follow the OSGI thing, so it doesn't pass my timeline much.
No, it passed my timeline a lot back then because there was the fight between OSGI and Jigsaw back then, and also modularization in Java. So I got lots of, I don't know why, I got lots of requests and my opinion about OSGI. As I was completely involved. Also, sometimes I had to use OSGI in projects, but usually I didn't, and but still was involved. But right now it's silent. It's interesting. Okay, but
Payara Server only uses OSGI as a module system. It doesn't use any of the other capabilities of OSGI, around services and things like that. So hence, in Payara's, it actually just uses it as a way to make sure that all the modules have the right versions and things.
Mm-hmm.
Which is why it can be stripped out from Micro. It doesn't really affect anything else.
Mm-hmm. And also the startup time is also comparable. I would say Payara Micro probably starts, 1 second faster, a little bit faster, but it's not like a huge difference, right?
No, because there's, startup time's not particularly slow anyway.
Yeah. And this is why, I was always a little bit against the Payara Micro, because on projects and conferences, there was like expectation like Payara Micro is the runtime you have to use in microservices are leaner, faster, and whatever. And was always my impression, it was assumed that the Payara full is slow, bloated, which was never the case actually. So it was like the completely wrong perception what Payara Micro actually is and what Payara full is. And I would understand if someone says, okay, look, you don't need the admin server. We can strip it away, so there is less security issues probably, and it a little bit faster. This is what I would get, but it was like completely wrong perception. And even in one project was interesting. So I wrote like how to call it I was involved in a best practice or a template, and there was assumed it only runs in Payara Micro because it's a microservice framework, and also I always tested with Payara Full. So there was like community perception like Payara Micro is the cloud edition, and the Payara Full is like the old stuff from 20 years ago.
Yeah, I mean the goal of Payara Micro really was to take the Payara server runtime and actually make it so you don't have to install it. Make it so that you're not following a domain model. You're building independent servers that can cluster together and discover each other, and make it so that you could do, HoloJar and UberJar and just command line boot. So it's really the boot stuff that's different between Payara Server and Payara Micro, in that there's no installation process. Mm-hmm. That was the goal of it really, was to build that non-domain model. Boot it differently, just provide it on the command line and make it simpler.
Yeah, this is what I actually want.
Obviously, multiple DASs clustering together in Payara Server has the same effect.
Yeah, but what I already thought about is to create a Payara Micro S2I image, because it would be easier to implement. Because in Payara Full, what I have to do is I either have to use as admin deploy command, or I will have to fiddle around with post boot scripts, and with Payara Micro there is more explicit, so I can just say Java -jar Payara Micro and then set the war, and this is more explicit what happens, right?
Yeah, exactly. That's the main difference really, is that it's all the boot and how you boot the server and how you deploy things is wrapped around the same kernel, but it's just targeted a different use case.
And from the commercial support perspective, are both servers supported equally well, or do you have a preference, or is it the same license? Or?
No, they're all both included in the support service.
Mm-hmm. And how about the development? Are you building, Payara Full first, or is it a Payara Micro branch? Or is it so? How the development happens? So how
Payara Micro is really a respin of Payara Server.
Okay.
So the core development is done on Payara Server, and Payara Micro effectively is a repackaging of Payara Server components into a single jar, along with a wrapper about how that runtime gets booted, and a wrapper that basically does a lot of the command line work. But other than that, it's the same kernel. That might change in the future as we go more and more towards, building more of a framework that may support things other than HoloJars, actually just be a flat class path type framework. But at the moment, the development is effectively Payara Server first, and then Payara Micro's respun from it.
So what you did technically, just as I'm curious, so there's this HK2 kernel, right, from the old kernel from GlassFish, is the module system, right?
Yeah, that's right.
And what you did for Payara Micro, I guess, is you just re-implemented HK2 to be hardwired? Is this what you did?
No, so HK2 is for both of them.
Okay.
Is the kernel for both. Underneath Payara Server is OSGI. So OSGI discovers the jars and builds the class path in Payara Server. Payara Micro, the class path is just the normal class path.
Yeah.
So where HK2 can then discover services that are on the class path on both of them. So
okay, so you have a Jenkins pipeline which it sets the class path statically in Payara Micro. A script or
basically Payara Micro uses a class path, which is obviously a normal Java class path, plus it loads all the jars from within itself.
Yeah.
Payara Server uses OSGI to set up the class path and load all the modules and all the jars up.
Yeah, but you have...
That's probably the only difference.
So you have to set the class path, or probably you wrote a script or whatever which generates the class path, right?
Yeah, there's a big boot wrapper around Payara Micro, which is all new Payara Micro code, which does all the command line handling and the class path building and things like that.
Mm-hmm. So now, are you still excited about Jakarta in micro profile, or what's your opinion on the current situation?
I'm glad that we can actually start moving forward. I would like to have moved forward maybe 18 months ago, but now we can actually move things forward in Jakarta EE, and I'm hoping that will get more exciting.
Mm-hmm.
It's been 18 months of long committee meetings, but not a lot of action.
Yeah,
mainly just because they work through legal details of the donation.
Yeah.
Now that it's come to a conclusion, and I'm excited to start moving it forward. I'm hoping that people will join in the actual task of evolving a lot of these APIs.
Mm-hmm.
Micro profile is still exciting. What will happen between the two is, I suppose, still to be decided. And actually, I don't really mind either way what happens. It can stay separate or join together. It doesn't really make much difference from our perspective.
Mm-hmm. And so now the question is the JavaX namespace issue. Are you for clear cut or gradual migration?
I think I'm personally for a clear cut migration from JavaX to Jakarta. So I'll explain why. I think which way you fall will depend on how many JavaX APIs you believe need to evolve.
Mm-hmm.
So if you believe that a majority or a large majority need to change and evolve, then any evolution requires you to cut over to the Jakarta namespace.
Mm-hmm.
So I think if you believe that a lot of those APIs need to evolve, then you believe that a Big Bang would be simpler, just to take everything and move it.
Yeah.
If you're on the sort of fence where you think maybe only 20%, 30% need to evolve, then obviously leaving a lot of things that are never going to change on the JavaX namespace is less painful for third parties and the rest of the community out there, because it's not just Java EE. I mean, it's all the other frameworks like Spring and everything that are also heavily affected.
Yeah. But
I think it depends on how many you believe need to change and therefore how many are going to have to move to Jakarta, whether you think that everything should move in one go or things should just move bit by bit. I'm on the everything should move in one go type camp.
Yeah, exactly. So I'm also absolutely for it, and I would move actually everything to the Jakarta namespace. And one of the reasons also, of course, marketing, because we can say, no, it's Jakarta E9. Whatever starts with Jakarta E or Jakarta is Jakarta, and the old stuff is JavaX. And this is also very, very clear message. This is a gradual migration, in my eyes, would be terrible, because we have old APIs with JavaX, the new with Jakarta, and this is really hard to learn, I would argue.
And you never know which one's which. And
this is
and if you suddenly decide that one you didn't think needs to evolve does need to evolve, then it has to move and then break applications at that point.
Yeah, exactly.
So I think if you go the incremental, you have to spend a lot of time in that analyzing what may or may not move, and that analysis probably just leads to another year of paralysis, really.
Yeah.
Whereas if you just move it, no one has to move to, the biggest point is no existing applications are currently going to break because they don't target Jakarta EE9.
Yeah, exactly.
They target Jakarta EE8. And if they never need to target Jakarta EE9, they're not going to break. And the application servers are going to, we're going to support the old namespace for many, many years because people will pay us to do it.
Yeah.
And And the new namespace, I'd say it's probably easier to know that everything's moved, and then all you got to do is change the namespaces on your apps and deploy them onto the new runtime.
Yeah, and there are no copyright issues left because it's complete new start, and then we are just independent, right?
Yeah, I was thinking long and hard about this because backward compatibility is one of the strengths of Java EE, but it's also one of the weaknesses in that we see a lot of applications where they're sort of half moved. People have moved them to Java EE 8 a bit but they don't actually know what the difference is between 8 and 7 or 8 and 6 in any great depth. So actually, they're probably a hybrid of some 8, some 7, some 6. And because the application servers do such a great job at supporting that the developers, to some extent, done a disservice in that they should be moving their application to the latest APIs.
Absolutely.
But they don't actually know what they are, and nothing breaks. So, nothing happens, if you see what I mean.
Okay. Yeah, absolutely. And by the way, for 20 years, we were absolutely compatible. So I think it's absolutely okay, every 20 years, to break the compatibility. I think this is, 20 years in software development is a long time.
Yeah, and I'd quite like a profile in Jakarta EE that is actually just purely, let's call it legacy free. So it's just the latest. Doesn't support old ones. So that people can take their application and actually find out what they need to do to make it run on the latest runtimes.
Yeah.
Obviously, as a seller of services around a server, right, I'm going to support backwards compatibility because that's what the market's going to want.
Yeah.
But it'd be good to have a profile where you can say you are compatible, but only compatible with the very latest release.
And this is my personal opinion, why I think that a micro profile should be independent from Jakarta, because the Jakarta is, for me, is like more boring, stable, base for application development. And micro profile is like more experimentation APIs, which some of them could even die. Like, for instance, this GraphQL could really die because who knows what happens next in JavaScript land, right? So keeping them separate lowers the risk that some part of the Jakarta platform may become, redundant in later releases, right?
Yeah, and I think we've got much more opportunity to do that within Eclipse Foundation than was before. I mean, both the E4J project as well can create projects that aren't part of Jakarta EE. So if you wanted to mess around with, I don't know, an API for service meshes or something, then it's possible to do that within the open source foundation, and that within the umbrella or branding of either MicroProfile or E4J. But then if it becomes successful and stable, then it could actually be formalized as part of the Jakarta EE platform.
Yeah, but from the outside view, if you are a developer which has nothing to do, who has nothing to do with, let's say, the Java EE or Jakarta EE or MicroProfile process, so what you see is like, two independent parts, like Jakarta EE and the MicroProfile, and the impression is like, okay, MicroProfile moves faster and Jakarta is a little bit slower, and there are runtimes like Payara which support both. So, and this is actually and they are actually separated right now. So in my Maven POM, there are two APIs, Java 8 and MicroProfile 2.2, I think, API. And so this is a clear separation, between both. And so far I know is MicroProfile will get 4 releases a year, and Jakarta EE will always move slower. So I think the separation, and it's like a microservice consideration almost, in MicroProfile comes with 4 releases a year, and I think this cadence would be not very good for Jakarta EE, right?
Yeah, I don't think we'll get to any cadence anywhere close to that, no. I think it'll be maybe 1 or 2, one, maybe, I'd like to see maybe one every, I don't know, somewhere between a year and 2 years.
Okay. So now the question, what is the country with most enthusiasm towards Java EE and MicroProfile? So you're traveling around the world, you're providing commercial support. So where is Jakarta EE and MicroProfile the most popular?
I don't know about specific country, but regional, I would have said Europe is probably most popular.
Interesting. Okay.
I would say it's quite a lot of especially, Central Europe, Germany. I think that there's a lot of interest in Jakarta EE MicroProfile.
And what is the craziest Payara project you know about? It could be commercial or something interesting.
Oh, that's a tricky one, isn't it? I know lots of crazy projects. I don't know. That's tricky. Well, you stumped me on that one.
Yeah, see? You can provide... We do it the next time on the next podcast edition. And what I know...
Yeah.
I was a few years ago in Poland in a conference invited. There was a workshop, and what they did is, I don't know whether they, back then, this was before Payara, but they used GlassFish for the European Space Agency, and they created like satellite tracking system with JavaE mesh or something like that. And they attended the workshop, so they need a scalable solution. There was a satellite communication system all with JavaE, but I have no idea whether they migrated to Payara or not, but this was at least GlassFish based.
Yeah, I know there are some big science institutes that are using Payara on some of the accelerators and things like that. I think in the UK, I think they're using it in one of the science institutes.
Okay. So cool. Where people can find you on the internet?
We're at Payara.fish.
Okay.
It's quite easy to remember.
Yeah. And you are on Twitter as well?
I'm on Twitter at LeetJava.
LeetJava?
Which is my ironic Twitter handle.
Yeah, cool. Yeah. So thank you. And if you have time, we should speak again, in half a year, 1 year. And
it's always a pleasure. It's always good to hear your perspective on it as well. I know you sit with a lot of customers and a lot of people using it who aren't customers, just to get, we're always keen to understand how people use it in the real world and what people want. I mean, so we're not VC funded, we're customer funded. So we're very keen to build stuff into the server that is, meeting people's needs.
Yeah.
So we always encourage people, if they find something that they think is a complete pain in Payara and just think, why does it do this? Why doesn't it do that? Then let us know, and we'll make it that.
Yeah, what projects really would like to have is this is really hard to tell, because what the customers, so the sponsors would like to have is like easy to understand software and short development cycles. So they would like to deliver fast. What the architects would like to have is like as the older architects is completely overbloated cargo cult architectures, which are no more sensible. And but this is a less and less project. We get something like this. Then younger developers would like to have exciting projects, and they are absolutely not interested in JavaE because it's too boring. So everything works out of the box. And seasoned developers, they are the most interesting to me. They just really would like to develop fast. They don't care anymore, about finding out what the best solution is. They'll give me a solution and I go with it. And what's also interesting, I'd say it over and over again, because I think this and last year I work more and more with startups, and they really like what they see with Payara and Java. And in the last projects we pushed Payara to AKS. This is Azure Kubernetes Service, and it worked actually perfectly. And,
we've done quite a lot of work to get it work. So
yeah, it worked out of the box. So what we did, we just said, we pushed the Payara full to a private registry, and then with AKS, it just this was no issue at all actually. And it also works in GCP and AWS. So this is what I do a lot with startups. And what I also see what happens is the back from public clouds to private clouds, where more and more clients are starting with OpenShift or even Kubernetes. Yeah. Because it's cheaper and more predictable, so we get the cloud stack in-house back. So what I never got why you should buy public clouds, because if you have the same infrastructure in-house, who cares about public clouds? And some are doing this already, so they are migrating back from public to private. But the programming model is the same. And what I also see more and more, so now developers find out that OpenShift is actually Kubernetes, so they can develop locally and then push to whatever client they like. And this is also an interesting trend.
So when you're seeing Kubernetes or OpenShift deployed into organizations, are they deploying it as a single solution organization wide, or are you seeing the sort of anti-pattern of a Kubernetes cluster per application in the old application server type model?
So what I see a lot is one Kubernetes cluster is like a stage, and within the cluster you have namespaces or projects, and this, yeah.
So they are building like one big Kubernetes infrastructure, because I've heard some people saying that people are doing anti-patterns of this, and I have our application, I'll create a Kubernetes cluster for my application.
And not for the application, for the organization. So
that's what I mean. So it is organization wide, and they're deploying it as an infrastructure like that.
Yeah, but this is like, this is the larger clients already have the OpenShift infrastructure in place. And in the smaller startups, this is what we can do. And if I have the influence, what we do is we have one, let's say, one namespace or one cluster for dev and integration or experimentation. And then one cluster separated is for production. And sometimes what we even do, in one project, we installed OpenShift on Amazon. So we tweaked it a little bit, and it runs actually OpenShift on EC2. You can do it with one click, and so you get this is what I see in the wild.
Okay, that's interesting.
Yeah. So thank you, and see you in future.
Yep. Anytime.
Bye.
Thanks. Bye.